There is a particular kind of loneliness that only physics can fully explain. Not the ordinary loneliness of a quiet evening, but a loneliness written into the deepest laws of the cosmos. A loneliness that may be permanent, structural, and absolute. The universe is not merely large. It is expanding, and it has been expanding since its very first moments. And that expansion has a consequence so profound, so deeply counterintuitive, that when you first encounter it, it almost feels like a cruel joke written into the foundations of reality. That consequence is this: there are regions of the universe so far away from us that no signal, no light, no radio wave, no message of any kind can ever reach them. And more startling still, there are regions so far away that even if a civilization living there wanted to find us, the mathematics of space-time itself would forbid it. Not technological limits, not a failure of engineering. The laws of physics, as we currently understand them, simply close the door. To understand why, we need to go back to basics, because the word expanding carries a meaning that our intuition almost always gets wrong. When most people hear that the universe is expanding, they imagine something like an explosion, a bomb going off in a room with debris flying outward from a central point. But that picture is deeply misleading. There is no center, there is no room. What is expanding is space itself, the very fabric of the cosmos, the substrate in which galaxies, stars, and planets exist. Every region of space is stretching, pulling neighboring regions apart so that the distance between any two sufficiently separated points is growing, not because those points are moving through space, but because the space between them is being manufactured moment by moment at every location simultaneously. Edwin Hubble gave us the first hard evidence of this in 1929 when he measured the recession velocities of distant galaxies and found something remarkable. The farther a galaxy was from us, the faster it appeared to be moving away. That relationship, now called Hubble's law, was a direct fingerprint of a universe in expansion. But the story did not stop there. In 1998, two independent teams of astronomers studying exploding stars called supernovae made a discovery that shook the foundations of cosmology. They expected to find that the expansion of the universe was slowing down, pulled back gently by the collective gravity of all the matter within it. Instead, they found the opposite. The expansion was accelerating. Something was pushing space apart with increasing vigor. We gave that something a name: dark energy. And while we still do not fully understand what it is, its effects are written clearly across the sky. Now here is where the loneliness truly sets in. Because of that accelerating expansion, there is a boundary surrounding us, a cosmic horizon beyond which no information can ever reach us. Think of it this way. Light travels at a fixed speed, roughly 300,000 kilometers per second. That is the universe's absolute speed limit, the fastest that any signal, any message, any piece of information can travel. But if the space between us and some distant galaxy is expanding faster than light can cross it, then light leaving that galaxy today will never reach us. It will spend its entire existence moving toward us while the space it is trying to cross grows faster than it can traverse. It is like trying to walk toward a destination on a treadmill that is accelerating beneath your feet. You can walk as fast as your legs will carry you, but if the belt is moving faster than you, the destination recedes and you never arrive. This is not a metaphor. This is the actual geometry of our cosmos. The observable universe, the sphere of space from which light has had enough time to reach us since the universe began roughly 14 billion years ago, has a radius of about 46 billion light years. That number already sounds impossibly large, but beyond that sphere, there exists far more universe, possibly infinite amounts of it, filled potentially with galaxies, stars, planets, and perhaps civilizations, all of it forever hidden from us, not by distance alone, but by the relentless stretching of space-time. And critically, the acceleration of that stretching means the cosmic horizon is not static. Over time, it is effectively shrinking. More and more of the universe is being pushed beyond the point where contact is possible. Galaxies that are currently just within our observational reach will eventually cross that threshold and vanish from our cosmic neighborhood entirely. So now imagine a civilization somewhere out there, intelligent, curious, technologically advanced, exactly the kind of beings we might hope to one day encounter. If they are located beyond our cosmic horizon, they face the same physical constraint in reverse. Any signal they send toward us enters a cosmic environment where the space between us and them is growing faster than the signal can travel. Their transmission would chase us forever and never arrive. This is not a problem of insufficient technology. It is a problem of space-time architecture. No antenna is powerful enough, no technology advanced enough, no method clever enough to overcome a universe that is pulling the destination away faster than the signal moves. But let us not stop there, because the situation becomes even more layered when you think about the timescales involved. The speed of light means that even within the observable universe, communication takes time. A signal sent from a planet 100 light years away takes 100 years to reach us. A signal from the Andromeda Galaxy, our nearest large galactic neighbor, takes about 2.5 million years. The vast majority of stars in our observable universe are tens or hundreds of millions of light years away. Even if a civilization on a planet orbiting one of those stars sent a radio signal the moment Earth formed 4.5 billion years ago, that signal would still be in transit, still crossing the ocean of space between us. The universe is so large that communication is not a matter of pressing send and waiting for a reply. It is a multi-generational, multi-million-year endeavor, even at the speed of light. Now consider the problem of navigation. If a civilization wanted not merely to send us a message, but to physically travel to us, the constraints become almost incomprehensibly severe. Special relativity tells us that nothing with mass can reach the speed of light. The faster you accelerate a massive object, the more energy it takes. And as you approach light speed, the energy required grows without limit. To reach exactly the speed of light would require infinite energy, which is physically impossible. So any physical spacecraft, no matter how advanced, is constrained to travel at some fraction of light speed. For a civilization hundreds of millions of light years away, a journey toward us would take hundreds of millions of years at minimum, even under the most optimistic assumptions about propulsion. And that is before accounting for the fact that the universe is expanding while they travel, potentially stretching the remaining distance faster than they can close it. There is a concept in physics called the Hubble length, the distance at which galaxies are currently receding from us at exactly the speed of light. Anything beyond that distance is receding faster than light can travel, meaning that even if you left today moving at light speed, you could never reach a galaxy currently beyond the Hubble length. For civilizations beyond that boundary, the mathematics is conclusive. They could not reach us even with a spacecraft traveling at the absolute maximum speed the universe permits. Now you might wonder whether wormholes could change this picture. Wormholes are theoretical tunnels through the fabric of space-time, shortcuts that could, in principle, connect two distant regions of the universe by bypassing the space in between. General relativity, Einstein's theory of gravity, does permit wormhole solutions mathematically, but every physical analysis we have conducted suggests that wormholes of the kind that could allow travel would be extraordinarily unstable, requiring exotic forms of matter with negative energy density that we have never observed and are not certain can exist in the quantities required. Furthermore, even if such structures could be created, there is no reason to assume they would connect the right 2 points in space-time. A wormhole opening near a civilization beyond our cosmic horizon would need to have its other end somewhere near us to be useful, and there is nothing in current physics that suggests nature provides such convenient shortcuts on demand. String theory, the framework that attempts to unify all the fundamental forces of nature by describing particles not as points but as tiny vibrating filaments of energy, does allow for a rich landscape of possible universes with different physical laws. Some researchers have speculated that higher dimensional structures in string theory might offer exotic geometries that could circumvent ordinary travel constraints. But these ideas remain firmly in the domain of theoretical speculation. We have no observational evidence for large-scale extra dimensions, no experimental confirmation that string theory describes our universe, and certainly no engineering blueprint for traversing extra-dimensional geometry, even if it exists. The physics as we observe it gives us no route past the speed limit. What about quantum mechanics? Could quantum entanglement provide a communication channel that bypasses the cosmic horizon? This is a question that comes up often, and it reflects a beautiful aspect of quantum reality, the fact that two particles can be correlated in ways that seem at first glance to defy spatial separation. When two particles are entangled, measuring the state of one instantaneously determines the state of the other, regardless of the distance between them. But the crucial word here is determines, not communicates. No information is transmitted in the act of quantum entanglement. The correlation exists, but you cannot choose the outcome of your measurement. You cannot encode a message in it. The no communication theorem in quantum mechanics is a rigorous result that shows entanglement cannot be used to send information faster than light. The universe, even at the quantum level, maintains its speed limit. So the picture that emerges from all of this is deeply humbling. We live inside a bubble of observable spacetime, roughly 46 billion light years in radius. Beyond that bubble, space is expanding away from us faster than light. Civilizations that might exist beyond our cosmic horizon cannot signal us, cannot reach us, and we cannot reach them. Even within the observable universe, the distances are so vast that communication at light speed involves timescales that dwarf the history of human civilization. And the expanding, accelerating universe is slowly but relentlessly pushing more and more of the cosmos beyond the boundary from which communication is possible. There is something profoundly moving about this when you sit with it, because it means that the universe could be teeming with life, with intelligence, with beings who look up at their own night sky and ask the very same questions we ask, and yet that teeming life would be forever separated from us by the very geometry of the cosmos. Not by hostility, not by indifference, but by physics, by the same laws that govern light, gravity, and the expansion of space. The question of whether we are alone in the universe is one of the most profound questions science has ever asked. But physics adds a second, darker question alongside it. Even if we are not alone, even if intelligent life is scattered throughout this vast cosmos, how many of those civilizations are locked inside their own cosmic bubbles, forever unreachable, forever unknown, each one an island of awareness in an ocean of expanding space? We may share the universe with countless minds and never once in all of cosmic history exchange a single word. That is the shocking truth. Not that the universe is empty, but that it may be full of life we will never know, separated from us not by lack of effort or technology, but by the deep structure of space and time itself. The cosmos is generous with its stars and its planets and perhaps with its life, but it is parsimonious with its connections. It builds light speed limits into the architecture of causality. It accelerates the expansion of space with dark energy. It stretches every horizon outward and every message thin. And in doing so, it ensures that each civilization, however vast its knowledge, however extraordinary its technology, lives out its existence in a universe that is, at its most fundamental level, built around islands of the knowable, surrounded by an infinite, unreachable, and forever silent beyond.